Hi everybody, this is Andrea from Forkbomb, and I'm here to tell you about the Zenroom virtual machine and its ecosystem. I am on the Zenroom homepage, zenroom.org, and I'm gonna jump to the specs. So I'm scrolling down here to the specs section, and I'm gonna start from the bottom right. So Zenroom is written entirely in C, meaning that we have binaries, command line for all servers on all the architectures. We have libraries for Android, iOS, and we also have a transcompiled version of Zenroom running as a WASP module inside an npm package, meaning that Zenroom can also run in the browser or in a node application. Zenroom can also run in very, very small IoT chips like Cortex-M, and we have bindings for most languages that you can ever need. Zenroom has a very tiny payload, so the binary is usually around a megabyte, and it usually needs around 500 Ks of RAM to do its computation. It's fully deterministic, meaning that given the same inputs, you will get the same output on any platform you run it on, which is crucial for a blockchain virtual machine. What can Zenroom do? So first of all, a lot of cryptography, meaning a lot of different kind of signatures, ECDSA used by Bitcoin and Ethereum, EDDSA, Schnorr. We can also do quantum proof signatures using the dilithium algorithm, which is one of the algorithms selected by the NIST competition this year. And very important, Zenroom can do a lot of blockchain interoperability for Ethereum, Bitcoin, and more. Zenroom can also do advanced cryptography, such as zero-knowledge proof or offline zero-knowledge proof, like ZK-SNARKs. It can do multi-signature, W3C verifiable credentials, and more. Possibly the most interesting feature of Zenroom is that it can be programmed in an English-like domain-specific language inspired by BDD or Gherkin, which is designed to be read and written by people with no programming background. I'm going to scroll down a little bit further. So here you have all the latest downloads for all the platforms, and here you have instructions to use Zenroom in JavaScript, Python, along with bindings for a bunch of different languages. I will jump to a demonstration of the Zen code using our online IDE and the Playground API room. I'm going to reload the page here. So when you land on apiroom.net, you will see something like this. So you want to start from the examples. Here we have an extensive library of examples to be used as a cookbook to write smart contracts. So in the beginning, you have generic scripts to do all sort of computation. Here we have a section for cryptography, so hashes. As you can see, we can do different kind of hashes, as SHA, 256 and 512, KDF, PBKDF, HMAC, and we have currently added a couple more which we haven't documented yet. Here you have features that you can use to create microservices using the Zenroom ecosystem. I'm going to go back to this. You have a quantum proof section, so dilithium signature and key exchange mechanisms such as Kyber and Interop. Our zero-knowledge proof / ZK-SNARKs flow, multi-signature, and verifiable credentials. So I'm going to jump to an example that can be easy to use by most people. So I'm going to produce ECDSA signatures of a string and an array of strings. So this is what a Zencode script looks like. The script is divided in 3 steps. The given step, where I load the data. This step is strictly read-only. In the second step, which is the when step, all the computation happens. And in the third step, which is the then step, the data produced in the previous step is formatted and printed out. So here I am stating my identity and loading my keyring, which you can see here. This is a bunch of private keys that can be used to do cryptography and Bitcoin as a blockchain interoperability. Then I'm loading a string, which is nested inside the JSON object, and I'm loading an array of strings, which is this. In the when section, I am first creating an ECDSA signature of the array, which I'm later renaming, and then I am creating a signature of the string embedded in the JSON object. In the last 4 lines, I am printing out the string, the array of strings, the signature of the array of strings, the string, and then the signature of the string. When I press run, the output of Zenroom comes out, and this is the string I loaded. This is its ECDSA signature with the usual RNS formatting, and the same thing happens for the array. In the bottom, we have a bunch of information about the execution, so the Zenroom version, the git commits, the curves loaded at the moment, as well as the memory usage and the execution time. So very important to understand is that this smart contract that I just executed runs here in the browser. So this application in this situation, it's using Zenroom, transcompiled in WASM, and embedded into a node package, an npm package. So I run it again. You see that the memory usage is always the same, and the execution time is always between 30 and 40 milliseconds. I want to tell you more about the blockchain interoperability. To do this, I'm going to jump to the Zenroom documentation page. So dev.zenroom.org. When you start here, you want to scroll down. We have an extensive documentation of the Zencode language, as well as how to integrate Zenroom in different kind of applications. I'm first gonna jump to the Ethereum scenario. So a scenario is in Zenroom an internal library that can be loaded at runtime and contains functionalities. So here I am producing an Ethereum private key. When I create the Ethereum key, then I will create the Ethereum public key. And based on that, so based on the private key, I'm going to create the Ethereum address. This is what the script looks like. Here, if you scroll down, you will see how to create a transaction and how to sign the transaction. And the same thing we can do for Ethereum, Bitcoin, as well as Hyperledger Fabric, Hyperledger Sawtooth, IOTA, and Planet Mint, which is a new blockchain, a rewriting of BigchainDB. You will now wonder what you can use Zenroom for in this situation. So using Zenroom, you can effortlessly build a browser-based multi-blockchain wallet. So imagine MetaMask supporting Bitcoin and all its derivatives, Ethereum and all its derivatives, plus Fabric and Sawtooth. And and the same wallet can run in the browser, or you can embed it in a PWA and have it run in a mobile. And with very little code modifications, you can also run it on React Native or as a backend application. So here you have examples. So now to embed Zenroom, for example, and in a Node application, the backend, how to run it in the browser. Yeah. So there is an npm package called Zenroom, and we have examples for to call Zenroom from JavaScript, Python, and other languages as well. Okay, this was the basics of Zenroom. Now I'm gonna jump to the Zenroom ecosystem. So I'm gonna jump to the ForkBomb on page, forkbomb.eu. Here we have the summary of what I've just told you about the Zenroom stack. This is, again, a page about Zenroom, so I'm going to jump over. I'm going to jump over to Zenswarm. What is Zenswarm? Within the EBSI project, EBSI stands for European Blockchain Service Infrastructure, we have developed a swarm of blockchain oracles technology. So we have packaged a Zenroom microservice into a node-based application to do mostly blockchain interoperability. So the oracle listens to a blockchain, waits for an event, and when a certain event is produced, then the oracle is triggered, a smart contract is executed on the oracle, and the oracle can reply by computing something, for example, for blockchain interoperability, or feeding the blockchain with data from the internet. For this, we have also developed a dashboard. So here you have a screenshot of the list of oracles active at the moment that the screenshot was taken. We have built-in monitoring for each oracle. Something you can not really see here because the screenshot is too small is that when each oracle goes online, it announces itself to the network using a W3C document, which is something I'm gonna go back on in a second. Okay, back to the forkbomb.eu homepage. After Zenswarm, I'm gonna show you Zenswarm storage. Zenswarm storage is a distributed key value storage for caching and sharding. Something I didn't mention is that all the code you've seen is open source. So here you have the source code of Zenswarm. This is the source code of Zenswarm storage, and under github.com/dyn/Zenroom you find the source code of Zenroom. So what is Zenswarm storage? Is a Tarantool-based distributed caching and sharding application that allows you to do key value storage, where both the storage and the retrieval are based on policies that are coded in the application. The last thing I want to show you is our W3C method. So we have implemented our W3C method initially for the EBSI project. The very first implementation we did was in order to allow the oracles to identify themselves, and we're now growing it to be more generic in order to accommodate human users, to accommodate web services, or to accommodate objects of different kinds. Our W3C method has a focus on cryptography. So in the W3C document, we have embedded public keys for all the signatures that we are capable of working with. including the quantum-proof dilithium signature scheme, and the W3C method provides you blockchain anchoring, meaning that when a DID document is produced, the DID service stores the DID document also on blockchain, and it stores the blockchain transaction in the DID document, meaning that the validity of the DID document can be checked on blockchain at any time. Okay, I think that this is all. I will conclude showing you the GitHub repo of Zenroom. So if you go here, you do github.com/dyn.zenroom, and here you can follow the development. Thank you very much.